couple of weeks ago, I was always hitting Claude's usage limits. And now I no longer have this problem by fixing a couple of steps on how I use Claude every single day. And I was able to do this without having to change or reduce my usage with Claude. So with that being said, if you're interested, let's get into the video. Alright, so to get started, first going to understand is how the contexts are compounding each other. So you can see here that on the x-axis, we have the number of messages we're sending to Claude, and on the y-axis, we have the total token consumption. So let's just say that we send in the first message to Claude. Claude is going to process our first message. And then let's say if we're going to send our second message to Claude, then it's going to take the message that we sent from the first message and the second message that we sent and process it in the large language model. So you can see that it will basically compound the message that it sends. So let's say we'll get to maybe the 20th conversation or the 30th conversation, maybe even the 40th conversation. Every time when we're having conversation with Claude, every previous conversation is going to compound it to the current one. And that's not only the problem. If we were to keep going like this, eventually we're going to hit a problem where we're going to hit something called the context rod, which here you can see x-axis, we have the input length for the tokens, and on the y, we have the accuracy. And based on this chart, you can see that as we're having conversation with large language model, we can see that the accuracy for the model start decrease. And that's where the AI start to hallucinate. And to prevent this happen, the first thing we need to do here is to make sure that we don't have a lot of context to start. And just to show you a practical example, here you can see I started a Claude Code session on a project that I built called book0.ai. And all I had to do here is basically do the /context, which you can see here, to check the current context usage. And you can see I haven't sent any prompts or any message at all. It has consumed like 19% of the total context window. That's 190,000 for the context already consumed without me having to send any prompts. And why, you might ask? Well, here you can see it tells you exactly why. So for the usage by category, MCP took 11.3%, right? Skills 2%, and the remaining here took the rest. So that's where the 19% come from, is that we have loaded a lot of context up front. So in this case, what we need to do here is to fix how much context we consume at the start, so that we can prevent the context compounding later on in the conversation. So in that case, the first step we're going to do here is to prevent the MCP tools for the initial context loading. And by the end of it, it will look something like this, where we have load nothing because we haven't triggered any MCP tools yet for the first conversation. So we're only loading when we need it, and that's it. So to do so, you can see here, this is what we have right now, right? 11.3% for the context window. And to solve this, we're going to introducing a feature from Claude, which is the enabling to search, which is an environment variable inside of Claude Code to use to activate the lazy loading mechanism for Claude Code MCP tools. So essentially what we want to do here is that we want to lazy load them when needed. So inside of configuration setting by default, it is set to auto, which will automatically activate when tool definition will consume more than 10% of the context window for the model. And just to give you an example, let's say if I were to have this environment variable here to turn off, you can see I'm consuming 11.3% initially in the context. But let's just say that if I were to turn this environment variable here to true to always be active, you can see that if I were to start a new context window, we're now coming down to 6% for the initial context, which is a big deal. You can see this is what we had before, which is 11.3%. By simply just turning this feature to always on, doesn't matter how much context window you have for MCP, it will always have that for you, right? Let's say if I were to turn this off, I'm just going to show you a real example. So if I were to cancel it, and here if I were to clear the context, you will see that if we don't have this feature turned on, we will have the MCP tools context loaded everything initially. All we have to do here is just adding this environment variable and set it to always to be true. In this way, it doesn't matter how much context you have for MCP, it's always going to enable the tool search, which will lazy load the MCP tools. But now, here's the thing. Even with the lazy loading feature enabled, MCP here still costs more tokens than the CLI. And CLI here is just another way to communicate to third-party apps. Maybe you're calling Google or like Subase or Vercel through MCP. You can do the same with CLI. And this will basically save so much cost for the tokens, which you can see for the token cost comparison. For the MCP with the lazy loading, when we try to index the tool, it will cost roughly around 3,000 to 5,000 tokens for just a lightweight tool search index. But for CLI here is nothing because model here already knows the CLI tools from training, so it knows exactly how to communicate it. And let's say if we're going to try to call a tool inside of our MCP, it's going to cost roughly around 800 to 1,400 tokens, depends on the tool. and it will get the full JSON schema on exactly how to call. But for CLI here, it's going to be nearly 0 because the agent knows exactly how to call, right? It's simply just going to trigger the command and say, hey, -- help. It will know exactly how to call, like what are the parameters it needs, and it doesn't really need to load all everything into the large language model at once. And it's doing that by using their own tools to find things relevant. And you can see that for the output overhead, it clearly shows that MCP loads everything, the full JSON schema. But for CLI here, it only uses like a bunch of tools like searching to find the relevant information and loading the right information to the LM here when needed. And you can see here that there's going to be a huge difference because it's going to consume less tokens every single time we're calling our third-party apps through the CLI. And you can see that what we can start doing now is check the third-party apps we're using already. Like for example, Subase, it offers MCP. But if we were to simply do a Google search, it also offers the CLI. And we can simply just gonna follow this page on how to install this on our local machine. And then we just instruct Claude Code here to use the CLI instead of the MCP. But you can see here that I have asked it to uninstall the MCP and have it to use the CLI instead. So that in the future, we're gonna use the CLI here to interact with our Subase. And of course, out of all the MCP tools that you have currently in your system, you can check to see which one consumes more token. So right here, you can see I have set the enable tool search to be false. So that it loads everything all in once. So now you can see we have all the tools here for MCP and we know that it took 11.3%. So all we have to do here is I'm just gonna, scroll all the way down and ask, out of all those MCP tools that we have, which one takes the most context? Which one consumes more token? And also, can you tell me the top 5, the MCPs that we have that consume the most tokens that we should be able to switch over to CLI? I simply just ask that question to the large language model, and it helps me to identify which one consumed the most and try to seek if there's any options that has a CLI version that we can switch it over. And as a result, you can see that it lists out the top 5 MCP that we can switch over to the CLI. And here is the options that we have. So total, it will save up to 64,000 tokens, which is 6.4% for the context. Now, 6.4% for context might be not a lot, but if you are compounding every single time with your conversations, that's going to be huge. And especially if you're using the pro version, not the max version, maybe you're using like Sonnet, which the context window here is only 200,000. And that's going to be 30% of the context saved in your conversation that's being saved through the MCP, right? So that's going to be a lot that you can be able to use. And it also points out exactly what is the CLI version that we can switch to. For example, the Sentry CLI, which is the actual CLI name that we run in the terminal to basically trigger the Sentry CLI over the MCP. There's also the Atlassian, Firecrawl, Google Calendar, and Vercel. So there's a lot of things that list out how much of your tokens you're saving using the CLI version. So then all we have to do here, just going to tell large language model to create a plan on exactly how we can be able to migrate over from the MCP to the CLI. So here you can see it proposed a plan. First, we're going to remove a couple of MCPs, right? The Firecrawl, the Sentry. We're going to install the CLI for the Sentry, Vercel, and maybe the Google, CLI. There's also the CLAUDE.md file, which is our system prompt that we're going to update to use the CLI over the MCP. And then we will manually disconnect those integrations inside of our connectors, inside of Claude. And here is the potential saving. Now, here you can see it has me some clarification questions. Like, for example, should we skip the Google Calendar because we're not even using that for the current project? So I'm just going to say yes for this one. So I'm going to say yes, remove. And then for the second one, should we keep the Firecrawl MCP because we already have the playwright and the web fetch, but the Firecrawl, scrape, and extract are uniquely good for some scraping tasks. So if we say so, then we'll say yes, let's keep that as well. Or you can also do some research, right? And also okay to proceed with step 1 to step 4. So I'm just going to say, yes, let's do that as well. So in this case, I'm just going to say go, and it will basically just going to execute this plan and try to do the migration over from the MCP to the CLI. Now, eventually here you can see the migration status table has fully complete. So these are all migrated from Sentry to the CLI, from the Vercel here to the CLI, and also from Atlassian here, you can also see is over to the CLI. And those are just the top 5 MCP that consumes a lot of tokens, and we just convert it into the CLI version. And of course, you can also further try to convert more if needed, but I'm just going to convert these ones just to show you a demo. So you can see that once we have this done, we need to authenticate ourselves, right? Because it does the installation, but it hasn't done the authentication. So the Sentry I have already authenticated, which is good. And the Jira one, we have to authenticate ourselves in a new terminal. So I'm just going to paste that. And once I have authenticated, which as you can see here, and to verify that the CLI here works, and you can see here that I can be able to view a ticket through the command line interface as well. So here, if I were to come over to a new terminal, I specify a ticket here and I click on enter, you can see it gives you a full description of the ticket. For example, the descriptions, the expectations, everything I need to do for this ticket is all split out inside of the terminal as well, so that the large language model here can also access that through the terminal. And furthermore, I have also tested inside of Claude Code session by saying, hey, why don't you take a look at what are the tickets that we have currently in our Jira board? And here you can see it has fetched those information using the command line interface over the MCP, and it has fetched all the information correctly. So the title, the summary for each ticket, and also how many comments do we have. And just to show you the difference, we know that before it was 11.6%. But now if I were to, set the unable tool search here to false and just check the context again with a new session. So if I were to do the /context, you can see if I were to scroll all the way up, what currently takes for MCP is only 3.4%. And that's a huge cut from 11.9% for just cutting a few MCPs, uninstall them, switch them over to using CLI instead, right? That's a huge difference. Okay, so once we switch back, and here you can see we have unable to tool search. Now what we can do is we can be able to further refine a bit more for skills. Because you can see the next up we have here, it takes us huge for the usage is the skills by category. So in this case, let's take a look at how we can refine that further for skills. So to refine a bit more for skills, here you can see I have prepared the prompts, and I'll make sure to put the prompts inside of our school community so that you can download it. So essentially what it does here is that it's going to do an audit for the install skills and propose what to cut and what to condense. And simply what I do here inside of Claude Code is I'll basically just reference that file and using the superpower here to plan this before we're going to do the executions. And right away, you can see that it has prompted me some questions on exactly what projects or what skills we should cut. And I'll just going to assign the one that we're going to remove. And then we also have our global cuts. So if there's any skills that we need to remove for globally, so for example, like the story tools, I can just remove that if it's like something that's not really relevant, right? I'm just going to click on next. And here you can see there's also some plugins that are flagged as overlap. So for example, the project loop here already has this cover, so we don't really need the Ralph loop. So these are all like some, outdated skills. There's also the feature develop here. Because we already have the build feature and superpower, we don't really need this. So you can see there's some outdated skills. Code Simplifier and code review here is overlap with Simplify. So I'm also going to remove that as well. And in this case, I'm just going to keep it that way and just going to click on next. And in terms of the scope, how much should we cut? So cut only, condense later, or we should also cut and condense for the top 6 bloated skills. And for demonstration purpose, I'm actually going to do both and try to see how this works. So you can see that it has listed out some top bloated skills that actually has a bunch of prompts inside of the skill. So in this case, I'm going to submit this and let's try to see what it does. Okay, so eventually here you can see we have all the skills are optimized, and these are the skills has removed, and these are the skills that has condensed. So what we can do now is that if I were to start a new Claude Code session and just give you, before I do so though, if I were to give you a comparison, that this is what we have right now, right? So you can see 2.3% for the skills. And now if I were to open a new terminal, and I'm just going to start a new Claude Code session again and type in /context. And you can see here that the result here, we went from 2.3%, which you can see here, right? 2.3%. all the way down to 1.7%. And that's going to be a huge drop. So what we can do now is that now we drop down from 6% all the way to 5% for initial context. So the next one up is basically our memory files. Here you can see it takes 1.6%. And let's try to see how we can be able to optimize that for our Claude sessions. And again, I also have created a prompt for how to audit the entire CLAUDE.md file for the system prompts, which you can also download it in our school community. And here you can see these are all still 5 things that we check and also additional things that we check for system prompt to do a full audit. So what I did here is basically try to paste that prompt instead of Claude Code and have it to basically using superpower here to audit and try to plan things before we're going to do the executions. And you can see that after if we were to do the condense and optimization, here is the change that we are optimizing for. And furthermore, we also have takes some loads from the system prompts here and extract them and save them into the reference file so that we can be able to have our system prompt here to be clean and having reference file loaded when needed. Okay, so that we doesn't have to load everything into large language model. So you can see that it creates a bunch of like guide files inside of docs folder, which is really cool. And furthermore, you can see this the entire preview. So final slim for the project.md. And we can get a hint of this, right? So eventually here you can see we have the memory file here has dropped significantly all the way from like so in this case, sorry, it's going to be 16,000, right? Which is the total tokens that we have and 1.6% for the context usage. And now you can see we're dropped to 0.7, which is a huge difference there. Alright, so finally, what I want to wrap up for this video is I want to talk about the settings and permission. Now, why is this important? There's actually 3 small configuration settings that by default is silently wasting tokens every sessions. And what we need to do here is we need to fix that. And the first one here is the auto compacting. So Claude here by default will auto compact at 83%, but it's really too late because that if you were to take a look at the graph that I showed you earlier for the context rod, by the time when it hits like 80% or something, you can see that the Claude accuracy here is already starting to decay. So what I would recommend you to do is start to hit the auto compacting early, maybe 75% or maybe like 50%, right? Whenever the Claude start to, lower the accuracy, that's when you start to auto compact. And what you can do to make this happen here is that instead of your settings.json, instead of the environment variable, you can change this for the auto compact for the override. And simply, you just give a number on exactly when it should auto compact. Now, once we have the auto compact figured out, the next thing we're going to take a look at is the bash output truncation. Because by default, Claude runs any shell command like npm test, npm run dev, npm run end-to-end testing. You can see that by default, Claude is going to cap 30 to 50,000 for the character counts. And the output will actually get cut off. So Claude only sees a fragment of it. And it will silently rerun the commands, asking for more and paying for the truncated outputs. And this retry process is actually taking a lot of tokens and also wasting a lot of times. So what we can do instead is that instead of the environment variables, we can also set this new environment variable called the max output length, which we can actually set it to like 1,500,000 for the output characters. You can set it more if you want, but I'm just going to set it here. And this way, Claude will get enough output for the first call, and there's no going to be silent retries anymore. And simply to do this, instead of our settings.json file, you can see I just added this environment variable, specify the output that I want, and you can set it more if you want, but this is going to be good enough. And next time we run it, there's no more going to be Claude retries. Okay, so that's basically the bash output truncation. And lastly, what I want to talk about is the permission deny rules. So if you're a developer, you know there's a thing called git ignore, right? You can be able to ignore things to commit every single time for your version control. For example, like your node modules, your dist, your cache files, you can do the same for Claude because there's no point for Claude to reading those files because these are artifacts, dependencies, cache directories that we don't have to Claude have to read it. So what we can do here is that instead of the settings.json file, you can see that we have our permissions. And what we can do is that instead of having to have a allow list, we can also have a deny list. And for that, I also had a bunch of things that we can deny. For example, node modules, dist folders, build folders if you have any. Because I have a Nest.js project, I also want to ignore for the Nest.js as well, package.log.json file, and also the coverage. Now, it depends on you. If you want to add the coverage, you can also do so. I'm just going to ignore that for now. But you can see that we can be able to remove those things so the Claude doesn't have to read those things inside of their context. Now, eventually here you can see that's how you can be able to stop hitting your Claude's limits. And in this video, I show you 5 different ways on how you can do so, like refining the MCP, refining the skill, refining the CLAUDE.md file, and also some further settings that you can be able to do, like permissions, audits, everything else that I have mentioned in this video. I will make sure to put everything, all the prompts that I use in our school community so you can download it and use it to stop hitting your Claude limits. So with that being said, if you do find value in this video, please make sure to like this video, consider subscribing for more content like this. But with that being said, I'll see you in the next video.